Good morning all. This is the Power Oak PS5B portable power station. It's one of these things where you can plug solar in, you can plug a mains charger in, you can even charge from vehicle 12 volts, and it's got lithium ion batteries, and then you can take the power back out through 12 volt sockets or USB or mains. It's got mains plugs on this side. Anywho, this has been out in my shed for about the last year, permanently plugged in via this cable to the big 240 watt 60 cell solar panel that I've got in my garden. And because this was only running a couple of USB devices plugged into these sockets, one was a Wi-Fi access point for the shed, the other one is the Zigbee hub. This thing was putting out very little power, and therefore it just was permanently fully charged. It's 5 bars. Occasionally I'd come out to the shed and see that it was just flashing and topping up, because of course these devices do drain this thing down very slowly, but most of the time this was fully charged. Actually, let's turn it on. Where is it now? Nowhere near fully charged, and that's because one day I came out to the shed and yes, it was down at this sort of level, wasn't charging. And I thought, wait a minute, it's still plugged into the solar panel. What's going on? So I thought, has the MPPT solar charge controller in here burnt out? Can't see why it would. So I went to take this plug out and it wouldn't come out. It was absolutely firmly jammed in there. So I thought, oh, we've had an incident. Something's melted and welded together. I disconnected this cable at the other end. Let's show you the other end. A couple of MC4s, and I put the wall AC power adapter in there. This can also take 12 volts DC from a car adapter, and it charged absolutely fine, so nothing wrong with the charging circuitry. But what happened to this? Well, it does come out now, but it took an enormous amount of force to get that out, and I'll show you why. We'll get some close-ups. So this is the Anderson power pole connector on the side of the power station, and as you can see, the metal blade on the negative connector has moved to the side. And that's because the plastic, the black plastic here, completely melted, welded itself to the plastic on the corresponding mating plug. The metal, because it's moved down, simply disconnected with the mating leaf. I suppose this is like a blade or a leaf. And therefore there was no longer any charging going on. But probably, oh, that's sliding off the bench. Probably prior to that happening, there was arcing, and the arcing created heat. Maybe not even arcing, but just a high resistance connection. And that's what caused the plastic to start melting. So here's the corresponding plug that comes from the MC4 connectors. Not sure if we can see any evidence there of arcing, possibly, but again, the red plug's fine, actually, completely fine. Everything's in its correct position, which is good, because that shows us comparatively where things are meant to be. But although the black blade doesn't seem to, the metal blade in the black plug doesn't seem to have moved significantly, you can see all the melted plastic, and in fact where it simply had to be torn apart in order to get this plug out of the corresponding socket. So there it is, an Anderson power pole connector which got hot, the metalwork moved, and it lost connection. Now, to my mind, this plug only works because the metal is in contact with the metal under some pressure by virtue of the plastic surround. If the integrity of the plastic surround is lost, and that could happen, I mean, that shed had got to 35 degrees Celsius, in the middle of summer. It did get very warm in there. Maybe this softened up a bit and those leaves moved. That started the arcing, and that caused positive feedback with a heat event, and the whole thing melted down. But to my mind, this says that Anderson powerpole is not a very good high current connector if you've got a warm environment, because it just fails. The metal to metal contact requires the integrity of the plastic surround to work. And there are other signs of a heat event. Before I pulled this out, these gouge marks are me trying to lever it out with a screwdriver. In the end, I just simply pulled it really hard by hand. But you can see there's a heat blister sort of thing here, a little bit of distortion in that straight line there. And on the other side, yeah, a little bit of a heat blister there. So there was clearly some sort of heat event that had taken place. Well, now I'm going to break open the shell of this plug, because having decided that Anderson powerpole ain't no good for a continuous connection with, at times, a relatively high current, possibly about 5 amps, something like that, I'm going to change it for something that won't have the same problem, and that's going to be an XT60. Well, look at this. This plug actually has a cord grip here, and the two wires run into the two connectors here. So the question is, will an XT60 fit in there, and will it also fit in the power bank, the portable power station? So I bought lots and lots of XT90 and XT60 connectors. These are the 90s. The eBay seller shortchanged me actually by one connector. These are AMAS. They've got AMAS printed on them, and they've got nice little mating cable reliefs, I suppose they are. So yeah, shortchanged me by one connector. However, the same seller on the XT60s actually gave me 50% more than I'd ordered. Not bad. So this looks like it could fit in there. I have to cut away that little stud, cut down these side walls a little bit, but I think that should go in there. That looks like a reasonably good fit in there. Now, which way around would this normally go? LiPo batteries have this sort of connector on them, so should I have that for the source? I probably should. Which means that this one, the male I suppose it is going to have to fit in there. It looks like it's going to fit reasonably well in this aperture. It might have to be filed out a bit, but the question is what's behind these power poles. Probably something very similar to what we saw in the cable. So positive, that's the flat one on XT60s and 90s, isn't it? And negative is the one with the angle. Odd that it went that way around, but there it is. So that just needs to fit in there. Probably sticking out a fair way. Oh no, this can be recessed, can't it? Because that sinks down inside there. Yeah, so this could be sunk down actually flush with this outside panel, which is ideal really. So if you're wondering what this is, I'll just lift that out. It's an EC3, I believe, or an EC5, which is direct access to the cells in here, and that's used with a crock clip cable for car jump starter. So this is going to have to come apart. I drilled these little covers so that I could put a screw in them and pull them out. Let's undo the screws, get the battery pack out of here, and see what we're dealing with. So there's the top coming off, there's the battery, and there's an EC3 or EC5 here for the main battery. So let's get that off. And this is with the bottom panel off, and I seem to remember that this is the balance charge lead. So we'll pull that out, and I think now this battery pack comes completely out, so I'll do that, and then I can get a better view of this thing. So this is the battery pack. This looks like the balance charge cable that's attached on the side here. with those 4 black wires. There's some sort of internal set of wires running there. Oh, I wonder if that's sort of coming in from the cells and then going off to this connector. Main high current connector there, and there's some sort of connector there which is possibly a temperature sensor, but yeah, that's the battery pack. That's what's written on it, 2019. I have had this unit for a while. And here's all the electronics. We've got this thing on a big heatsink with semiconductors in there, and then this is the inside of the lid. So I'm going to have to get in to the point where I can get to the Anderson power pole connectors. Now where are they? Oh no, that's the main side. Yes, this side. There they are. So you can see the red one there and the black one sitting next to it. I've got to get into there somehow. So there's the socket assembly with the 2 Anderson power pole connectors. Now I've undone that screw, but the other screw for that is buried behind another connector, which is this big one here for the jump start, and I think all of it is behind this stick-on faceplate. It's a plastic. I don't need the torch for that. Well, perhaps I do. But if I stick my screwdriver behind that, I can lever that off, starting to lever that away. But I think I might need to get some heat on that to get it off. It's the only way I'm going to be able to get to the screws, so if I damage the self-adhesive, well, so be it. Right, that's that torn off, and I can see a couple of screw holes, that one there, and the module for the AC and 12 volt DC input and the PV input should come away completely, and I should be able to get that out and start working on it separately. So that's come out. Just need to cut this cable tie there, and this is on a couple of plug-in connectors on the board, so hopefully I can get that all off. And that has extracted this wiring assembly, and in fact you can see that very simply the Anderson power poles are just in parallel with the other socket input. It says don't use them at the same time, but in actual fact all that would do is parallel the solar panel up with your constant voltage DC supply. The solar panel would then just immediately go to that voltage. I can't see that it would do any harm actually. And that's on a couple of spade terminal receptacles. Anyway, I want to get into the Anderson power pole section of this, see if I can replace it with an XT60. So having removed this top holder bar, the Anderson power poles should slide out. I do think though that because of the heat event that might have melted itself. Oh, that one's sliding out, but this one might have melted itself on there. I'll have a closer look. Right, this has come out of here, but because of the melting the little stud there has broken off there, but I don't think that's a bad thing because that would have been in the way of the XT60 anyway. So now I want to get this out and maintain or recover as much of the wire length as possible. These are slid together, aren't they? But I'm not sure they're going to come apart now because of that little pip in there. So it's a case of getting this in here, and I think the little channels, because the Anderson power poles have these little channels running down the outsides, they're duplicated in here. So if I carve them away, pos to the outside, so yes, that should fit in there quite well, and possibly I can just hot glue it in. I'll see how things look when I've carved this. So knife blade for the side walls. The remainder of this pip I'm just going to take out with, oh, that shot across the room, with my side cutters. Just got to remove that bit of side wall now. That is a really nice fit in there, but there's nothing to prevent that sliding back at the moment. But I think if I carved away more of this bottom rail, point this thing here, then this small lip should sit, got to get this the right way around, positive to the outside, yeah, it should sit inside there, and then I should be able to screw this back onto the top. Now this won't currently push down properly because I just need that to sit a little bit lower in this housing, but I think that is going to be a fantastic fit. Is there a lip there? There's some sort of lip. Yeah, so that should hold the XT60 in there, and if I just pack it with hot glue, I think that could work. So a bit of carving of this front wall because it's a bit too high for the XT60, so carve that away. Yeah, just want to reduce its height ever so slightly. Hard to see what's going on because it's all black plastic, but you can get an impression. Perhaps that'll do it. Now, is that held in by the two screws on the top? It seems okay, but it did pop out just now. I mean, it's at a slight angle, it doesn't sit quite straight in there. I do think packing it with hot glue would help, because yeah, it is possible to push it out, and I don't want that pushing into the unit and then being unable to reseat it, so I think I will pack it with hot glue. And now I need to remove these Anderson power pole connectors, and I can't quite work out, they won't slide apart because that pip's welded in there, so I'm just trying to cut them apart. Don't quite know how you solder these. I presume you solder the metal blade onto the wire and then slide it in, and there's some sort of barb which locks it in, but I don't know how they work. Well, it does seem that there's a piece of flat steel in there, and I'm pulling on the connector and it just seems to be hooked behind it. So if I guide it over the top of there, will it come out? And it's come out so far. So maybe the spring steel is intended to push the metal blade in contact with the mating part, but of course if the whole surround melts away, then the integrity of all that system is lost, and that's what happened. Well, I've been carving this apart. The metal is most definitely bonded into the plastic, so that's not coming out. But I think these look like they're long enough if I cut them at that crimped joint there. So I'll cut that tight up to the crimp. Similarly with the black one, if I can get in there. Yeah, so that's got rid of the Anderson power pole. Excellent. Now I can solder these into there, but I think I'll do my hot gluing of this first. Actually going to do the soldering first. So let's get these tinned up. Now that solder's too long on my... I can't manipulate it with my fingers very easily. Oh, that's not taking very well. Need some more heat. 400 should do it. Let's bring it up to that. Now let's see if it'll take the solder. Oh yeah, that's better. Bit of a horrible bit there. Let's get that nicely saturated with solder. And the same with the red. Oh, let's just tighten that up a bit. Oh, I can feel the heat coming up the wires now, particularly that black one. Oh, I don't know what this wire is, but it's not tinning very easily. And now I can see whether this connector, which does say AMAS on it, whether it melts when I heat it up. Shouldn't do, should be a thermosetting plastic. Oh, a nice hot iron works well in there. That takes very quickly. That's good. Now, is clipping this cover on going to be a mistake? Because that might remove this ridge and therefore it'll slide back through here. But if I hot glue it, that should bond in with this XT60 marking and fix it in there fairly solidly. So I'm going to clip that cap on. Oh, how do you get them on? Oh, like that. Okay, got my paws onto the flat side, that's correct. Right, let's get some hot glue and get that in there in such a way that it doesn't come out. Right, that's definitely pos to the outside. Car adapter is that one. PV, pos to the outside, neg to the inside. Let's glue it in. I'm just warming up my hot glue gun here. Right, I think the glue gun should be hot. So glue into the bottom of this. Let's put enough in to fill that up. That should be about right, I think. And stick this in before that sets. Now it is going to ooze everywhere, but that's fine. And then I want to put a bit of glue on the top, just over that AMAS logo. Not worrying too much about the strings. And stick that on the top and screw these screws down. And screw the other one down. That's nice and tight. There's another screw somewhere there, and put that in this side, and that holds the DC barrel jack in place. But that should all amalgamate together, and the XT60 shouldn't push back, but I'm going to let this cool and set completely before I attempt to play with it. And now, using a slightly safer knife, I'm going to carve away the hot glue that just oozed out the front, because it's just fouling. Oh yes, that's very nice. Little sliver of hot glue there. It's just fouling on this plate, and actually that is an exquisite fit in there. Almost an interference fit in the hole there. Yes, that's absolutely near perfect. Couldn't be better. So now this assembly needs to go back inside the lid, and it comes out this hole, if it will fit in that hole. It should do. It's struggling a bit at the moment. No, that should fit in there. I just can't get the angle on it. Right, let's put these retaining screws back in, which hold the assembly to the box lid, which is plastic, and the bottom one to hold the DC barrel jack in place. Yeah, that looks pretty good. That protrudes just the right amount. Let's test that with this convenient one sat here. Oh yes, and I can put the necessary force on there, although I should be careful until the hot glue is completely set, but that looks pretty good. And then this needs to fit over the top, which I think it will. I'll have to get some double-sided tape to stick that back on. I'll turn this up so you can see it face on. And here it is with the box all screwed back together again. There's the connector, that fits in there. And yes, I can add enough force to force that in and to pull it out, and my connector is not moving. And the nice thing about XT60, which the Anderson power pole doesn't really appear to have, is that when the metal is in contact with the metal, this is a cylinder, that's a sort of split pin, the integrity of the plastic is really unimportant, because once the pin is in the metal receptacle, that's it. There's no possibility for things to move and drift, and for heat to be generated, and for the whole thing to melt down. This is a thermosetting plastic, of course, anyway. But yeah, I think that looks much better than the Anderson power pole thing that they had before, and I was lucky, everything just seemed to fit. And then when I get all this sticky stuff off and get some double-sided tape, that fits on there rather well. So yeah, it's all going to go back together quite nicely, I think. And then the only thing I need to do now is to remove these Anderson power poles from the plug, and again put the XT60 in, which again might be hot glued into there. The two halves of this probably actually best held together by just filling it with hot glue. I can do that in another video if you're interested. You may not be, but for this video that's kind of it, so cheerio.